Thanks everybody for coming and surviving till the very last talk in this session. So we are physicists from DESI, German Electronic Synchrotron, and we want to share our experience, our adventures in AI world. So a couple of words about us, what we're doing. So we're building a next generation telescope array, which will consist out of such a big group of telescopes. So it's about like 50 and yeah, thank you for inviting us and coming to our talk. So I will skip introduction. Yeah, okay. So what we are doing? So we're building next generation telescope array. So it's two arrays of telescopes in each hemisphere. So one is located in the southern hemisphere in Paranal. It's kind of a desert in Chile, nearby European South Observatory, and the other side is on La Palma. And so this new array will be like 10 times sensitive than the previous ones. So you can check for a previous one in Google in your free time, like a HESS, MAGIC, and the Veritas telescopes. So and what these telescopes are doing is just a sample a cascades in atmosphere with a very high frequency. So we literally make photos of 10 nanoseconds length. So it's extremely fast electronics, and then we kind of combine them into pictures and doing our data analysis. So in a few words, it looks like that. So here's our data flow. So our raw data is 6 petabytes a year. But of course, we're doing some real-time analysis and downsample the data, so it could be stored on site because, again, so we work in kind of harsh conditions over there. So it's a quick intro on us, what we're doing, and I guess now Julian can give a bit more intro on AI and how it appears in physics.
Yeah, so this is a little bit taking a step back and looking at the meta level. And observe what, just to recap how we view the scientific process as a whole is this 4 parts where it consists of a hypothesis phase where you theorize and maybe make some theoretical predictions, and then you have to implement this in an experiment to validate the real physics. You analyze, you process the data, and you interpret them. Come up with a conclusion that you're going to publish so other people can learn about what you did. And you will repeat this in a loop, or you will catch up on other people's work and do the next iterative phase. In modern language, this could be an agentic loop. However, the last frontier in the physical world is not yet totally covered by AI. Because it requires to build huge infrastructure and operate it safely. And this is, of course, built on top of many billions of dollars of investment of taxpayers' money. So you have to be careful with this. And to study the physical world, you have to make experiment in the physical world. And if you want to have AI do it, it's going to be tricky. So I wanted to take even one step further back and see what automation in science has brought us in the past. So I've come up with 4 examples. They're very selective and not exhaustive at all, and I'm not a historian, so please bear with me. But I started here just at the end of the 18th century, where the task was to calculate mathematical tables so people can look up the results. And this was a very tedious task. But French mathematician de Prony came up with a hierarchical system where elite scientists would come up with the formulas and let a fleet of experienced specialists plan out the calculations and distribute the work. And then there were actual human workers to just follow some algorithms and come up with the numbers. And these were, back in the day, there were women that were unemployed due to French changes in the politics. So before that, there were hairdressers doing the wigs And then so it's very interesting how people were used to automate these things. But later on, other people tried to, an English guy named Babbage made this into a physical device, these just algorithmic computations. And so this is one example. Another one is just just barely 100 years later, where again women were used or were employed to analyze data. So this is one level higher now, where automation takes place on a more cognitive, more interesting level, and it's just again using automation in a sense to deal with the increased number of data that you get from technologically advanced observatories. And on the right-hand side, you can see an astronomy science image where this is very meticulous tasks of identifying and classifying objects in the sky. And this is, it's remarkable work. And this, led the path in science forward. And the next thing is, of course, all work that is taking place surrounding the NASA space program and the moon landing and the race to the space, and so on. So human computers were again used, but this time again one cognitive level higher, where people were used to compute really mission critical elements. And so this is in connection with also electronic computers in the later stages, where the computers weren't as reliable, and humans needed to really verify the work. And this elevated again the sort of socio-economic status of these workers. And it's just an interesting observation that over the past in science that these people were used to automate the tedious and meticulous tasks. And in the modern academia, if you I phrase it relatively straightforward, where we have a system that is called publish or perish. Senior scientists lead the way and fund projects and supervise younger scientists or students to make the work to do the work. Luckily, this is now a more diverse population doing this task and elevating their status. And it's basically the academic process of recruiting new senior scientists in the future, and by publishing, they will gain reputation and experience to do this loop over and over again. But now, AI will disrupt this loop. So if you separate research into groups, one with clinical value, where you develop, for instance, drugs that can save lives or increase your lifespan. There's a lot of people say this will increase welfare, and if you assume some AI recursive self-improvement step in the middle, which is questionable, but this might lead to exponential increase of human welfare, driven by the adoption of AI in these fields are mostly driven by economics. And then on the other hand, where we would place ourselves is fundamental sciences, where people are working because of idealism, not of financial gains. And here the problem may arise where AI use or automation in the scientific process will sort of stop the recruitment process, because younger scientists are not anymore incentivized to learn, because they will use AI. And this is all within this economic incentives for people that lead the AI economy and try to scale, where they build data centers in the space, and which might even be critical for astronomy and for us. So I'll leave you with this open questions and just hope I made you a little bit more aware of where the scientists are, what are scientists debating right now, and you can follow up on these papers. I hope, the QR codes will not be legible, I think, for your phones. Sorry.
Okay, yeah, thanks. Let's go further. So now let's come a bit to the Earth. So how we, as a group, few people began with LLM in physics, large language models, and our journey actually started before ChatGPT. So when OpenAI provided a kind of early access to embeddings, so we immediately tried and started to jump into this LLM hype train. And later on, it's appears a lot of papers, even in very high-ranked journals like Nature, Science, and so on. And what I observed when I preparing this presentation, so I see it's like a 10K accesses of the paper, reads, and only 2 citations. And here's 11 citations for the kind of same amount. And first I was thinking, okay, maybe it's an error in calculation, but then I opened one of paper where I took part in writing this, and it was a conversion factor, I would say 200 or so. So it's indeed looks like people really, I would say, enthusiastic about publishing, and the journals also accepting this, but in the end it has kind of a low conversion of scientific result into further progress. And of course, the companies itself also kind of feed this hype train, that GPT derives a new result in theoretical physics. Of course, it depends what we call result, right? So for somebody it might be result, for anybody else might be just a simplification of some formula. Yeah, and also our colleagues, scientists, also became very enthusiastic about this and add, for example, this work. So author just added Claude as a co-author. So it's already, our colleagues start to acknowledge AI and give them the same, I would say, same acknowledgements, yeah, same rank as to ours. And of course, progress still continues, and there is also kind of more natural named publications, very interesting ones, and people honestly accept, okay, so we used AI, and AI help us to derive some results without this very enthusiastic that AI built a new scientific result and so on. There's also some examples, and one of the recent results from Chinese colleagues at Chinese Institute of High Energy Physics, so they did a lot of work on this, so they really mark the data, so they use so-called domain-specific language to help AI to build a new analysis pipeline, and to me it seems like a really step forward into understanding and reasoning how it can be done in our case. Yeah, so, and parallel to this meeting, there's AI for Science organized by Helmholtz. I mean, people who live in Germany may recognize this. And actually, the topics which are discussed kind of the same as here. You can see it. So I will let you read it quickly. And of course, it also was a nice talk by Uwe. What's happening in science, and it's kind of very resonant in many fields. And there is also kind of a European consortium for AI and physics, and one can see which working groups we have there, and of course foundation models and discovery, and there is a initiative to build large physics models. So it's very ambitious project, and of course, given the funding situation in science, is kind of unclear how to arrive to the result, but people working on this anyway. Yeah, and now let's come even more to the Earth. So what's happened if replace myself with AI? Yeah, so I would be happy if somebody could do this. Yeah, and a friend of mine actually done this. So we use an open data to reanalyze a very old detector from a Karlsruhe. So it's like small boxes with detectors to detect the particles from the sky, and this some plots from my paper. You can see it's based on random forests, and the confusion matrix quite bad. And So a friend of mine from industry, so he just put my result into agentic loop and asked agent just to, okay, improve this, build your own models. Yeah, it's kind of a data for your understanding. It's doing some classification, so I will not, pay many attention to this. Yeah, results was quite good. I guess this one is a baseline, and so actually agent arrived quite quickly to better results. Okay, and yeah, but this has some limitations. So for example, data and simulation we provided, as well as a quality cut. Quality cuts means how we filter the data in science, and feature set. Yeah, but architecture of classifier and all stuff actually done by agent. So in principle, I would say it was halfly replaced by AI. And of course, there's a lot of room for improvement. Yeah. Oh, I think I switched to conclusion already. Yeah. So yeah, indeed. So since they're tireless, so we can run them for quite a long time. But we need to also take into account that metrics based on simulation and real data are slightly different, and there is some headroom is left for this. And maybe Julian can summarize our findings.
Okay, so maybe you observe the parallelism of things happening at the same time, people trying to make them obsolete themselves by employing AI, and scientists warning about the repercussions. So what is being discussed in the scientific community, is, at least in astronomy and mathematics, is that the process should be adapted, and the incentive structure needs to adjust. Otherwise, the scientific process will collapse, and new students will not come about again. On the other hand, there's a lot of efficiency gains to be had when using AI agents to do the work that we find tedious today, and be able to do more in parallel by becoming prompt alchemists and just using this technology in our ways. There's massive headroom in the technology, so even if you cut technological progress in model training right now, there would be a lot of things you could still improve by using these things and adjusting them to our use cases. So if AI comes to the physical world and we can use the models to just come up with experiments, or to operate these experiments and analyze the data, we can even further improve the models themselves by making scraping all the parameter space for training data and generating reinforcement learning environments to train the models, and just climb up into this exponential, or exponential growth, also utilizing it for science. We will see. It's unclear where it's going, but everything is happening in parallel. And thanks for the time to speak here and listening to us. So if you have questions, just raise your hands.
Okay, maybe we have 1 minute, so if you have a quick question, feel free to ask. All right.
Thanks. Sorry if this question is a bit broad. Thank you for the presentation. It was great. On that last slide, you said the agents aren't very good or don't invent. Why is that?
I mean, people are talking about emergent qualities of AI, right? Where you see behavior that you didn't put in during training time. Otherwise, you would expect that models are capable of just repeating linear combinations of training data again and again. And it's a question mark if the emergent behavior is really there across the board and can be used or harvested in fundamental sciences. So at the moment, I would say it's not really there.
All right. Thanks, guys. We are going to close it here. So now the sessions are over, and there will be like a closing session downstairs. Thank you.